Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is Cambridge Physics 5054 course, and I'm your teacher, Mariam Rafique. Today we're gonna discuss chapter number 18, and the name of the chapter is Current Electricity. Before getting into the core concepts of this chapter, I would like to share some learning outcomes so that by the end of this lecture, you will be able to understand that what is Ohm's law applications and limitations, resistance, resistors and some of its types, the concept of resistivity, and some assignment questions. Here is a little history about George Simon Ohm. George Simon Ohm was a German physicist born in Erlangen, Bavaria on March 16, 1787. As a high school teacher, Ohm started his research with the then recently invented electric cell, invented by Italian Alessandro Volta. Using equipment of his own creation, Ohm determined that the current that flows through a wire is proportional to its cross-sectional area and inversely proportional to its length. Using the results of his experiments, George Simon Ohm was able to define the fundamental relationship between voltage, current, and resistance. Unfortunately, when Ohm published his findings in 1827, his ideas were dismissed by his colleagues. Ohm was forced to resign from his high school teaching position, and he lived in poverty and shame. However, his research efforts gained a lot of support outside of Germany. In 1849, George Simon Ohm was finally recognized for his efforts by being appointed as a professor at the University of Munich. So Ohm's law states that the current through a conductor is directly proportional to voltage. We use inverse of resistance as proportional constant. So the mathematical form of his law is I is equal to V over R. Here I, V and R for current, voltage and resistance. So we can say that the potential difference, or you can say voltage, across an ideal conductor is proportional to the current through it. The constant of proportionality is called the resistance. Ohm's law is given by V is equal to IR, where V is the potential difference between 2 points which include a resistance R. Here you can see that I is equal to V over R. I is equal to current that can be measured in amperes. V is voltage and the SI unit of voltage is volts. And R is the resistance that can be measured in ohms. These are the different orientations of Ohm's law, and it will help you to remember the formula in different forms, like V is equal to I into R or I times R, I is equal to V over R, and R is equal to V over I. So if one parameter is missing, by the help of others two parameters, we can find out the missing one. From Ohm's law, we can measure resistance and voltage, and the formulas are for resistance, R is equal to V over I, and for voltage, V is equal to IR. Advanced level laws such as Kirchhoff's, Norton's, and Thevenin's are based on this law. And DC power supply is employed as power source for different components in labs. It provides variable output voltage based on the resistance, and the overall working is controlled by Ohm's law. The working of heaters, kettles, and other equipments also follows this law. Mobile phone and laptop charger. Mobile phone and laptop chargers use DC power supply in operations. As described earlier, that working of this supply depends on the Ohm's law. Resistive filament bulb. Although not widely employed today, the old days filament bulb holds the application of P is equal to VI, a modified form of V is equal to IR. The other equipment which uses similar applications of law in their working are all named here. For example, electric iron, rocket, the other equipment which uses similar applications of law in their working are all named here. For example, electric iron, rocket, spaceship, solid state electronics, BJT transistors, some amplifiers, MOSFETs, cell phones or any electronic circuits, wiring and working of small, medium, large, mega-sized IC and discrete circuits. The limitations of Ohm's law are explained as follows. This law cannot be applied to unilateral networks. A unilateral network has unilateral elements like diode, transistors, and etc., which do not have same voltage current relation for both directions of current. Ohm's law is also not applicable for non-linear elements. Non-linear elements are those which do not give current through it, is not exactly proportional to the voltage applied. That means the resistance value of those elements changes for different values of voltage and current. So examples of nonlinear elements are thyristors, some electric arc, and etc. Here ohmic versus non-ohmic resistors are shown by some graphical representation. Ohmic resistors are the resistors that obey Ohm's law, and any increase in voltage creates a linear increase in the current. That is represented in the graph. Slope is equal to 1 over R. On x-axis there is voltage, and on y-axis there is current. While non-ohmic resistors are the resistors that do not obey Ohm's law, any increase in voltage creates a non-linear increase in the current. So the resistance of the material changes based on the current moving through it. And you can see that this graph is not linear. Now, what is resistance? Resistance is a measure of opposition of current flow in an electrical circuit. Resistance is measured in ohms, symbolized by the Greek letter omega. Ohms are named after George Simon Ohm, 1784 to 1854, a German physicist who studied the relationship between voltage, current, and resistance. As you know, we have studied this earlier. Now, what is resistor? A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate transmission lines, among other uses. Now, what are the effects resistances? The electrons, that is charge carriers, want to get through this straight wire. The atoms vibrate as they are at room temperature. So what shape would we want the resistor to allow the electrons to go through? Now there are some types of resistors like fixed resistor and variable resistor. First we have to see that what is fixed resistors. Fixed resistors definition is that fixed resistors are the resistors whose resistance does not change with the change in voltage or temperature. So fixed resistors are available in various shapes and size. An ideal fixed resistor provides a constant resistance under all environments. And you can see the symbol for a fixed resistor in the diagram. Now what is variable resistor? A variable resistor is a resistor of which the electric resistance value can be adjusted. A variable resistor is in essence an electromechanical transducer and normally works by sliding a contact, you can say wiper, over a resistive element. And these resistors are called digital potentiometers. Here are some types of variable resistors like trim pot, sliding potentiometer, rotatory potentiometer, rheostat, preset, and Surmit. Now we have to see that what is resistivity. Resistivity is a property of the material. It is how well the material conducts electricity. The formula for the resistivity is ρ is equal to R times A over L. And this formula shows that the resistance will increase if ρ increases or the length increases. So the resistance will decrease if the area increases. And we can define this formula as R is equal to ρ times L over A, where R represents the resistivity, ρ is the coefficient, L is the length of the wire, and A is the cross-sectional area. Now this is time for assignment, students. Here is a think, pair, share. And these are the quick questions. Please see these questions and try to solve this. Thank you so much and good luck.